Hey, Algebra 2, welcome to section 13.4. Okay, we're going to evaluate inverse trigonometric functions. So kind of continuing our studies of trigonometry, we have about 3 more sections after this left of this chapter as our semester comes to a close. All right, so objectives for this section, we have define inverse trig functions and their domain and ranges. Evaluate inverse trig functions both in degrees and radians. Okay, kind of continuing our practice, trying to be fluent back and forth between those two units, right? And then solve trig equations using inverse trig functions. Okay, so before we start with that, let's kind of just do a quick little run through, practice a little bit with our unit circle, right? So for example, what if I asked you what the sine, I can write that a little bit nicer actually, sine of 240 degrees. Okay, if I asked you that, what would that be? So we would look at our unit circle, we'd look for 240 degrees. And then remember I'm asking you to, or I ask you to always draw yourself a little picture to go with it so that I can see that you're using the unit circle correctly. So I want to go ahead and draw where my 240 degrees is. That's going to be right here. Okay, my ordered pair at that angle. Okay, 240 degrees. My ordered pair at that angle is -1/2 comma negative square root of 3 over 2. Okay, and remember, if I'm looking for sine, think back to our section 13.3b. Sine of theta was y, the y value. Cosine of theta was the x value for all these x comma y, all these ordered pairs on our unit circle, right? And so our sine in this case is going to be the y value, which in this case is negative rad 3 over 2. Okay, so that's the sine of 240 degrees. And I can kind of do the same thing with a couple other ones. Now I'm gonna, for the sake of the length of this video, I'm gonna kind of do these a little bit quickly. You should always show your work, but in this case, I'm gonna kind of skip through that process just so we can kind of get to the idea of this video. Okay, so what if I asked you to find these two trig functions? Okay, cosine of 5 power 3, 5 power 3 is right here. My x value there is 1/2. So my answer there is 1/2. And then for tangent of 5 power 6, here is 5 power 6. Here's the ordered pair there. Remember that tangent, if theta is equal to the y value divided by the x value. So in this case, I have 1/2 divided by negative rad 3 over 2. And I'm writing it like this because I'm having to divide fractions. So this will help me realize, oh, that's just 1/2 times -2 over rad 3. Those twos will simplify each other out. We are left with -1 over rad 3. Okay, so just kind of a quick review of how to use our unit circle, right? Now this specific unit circle is the one I would like for you to be using, or the one that you have in your notes. And the file for this unit circle, this picture, will be in the Canvas shell right above the link for these notes, the submission box for these notes. I encourage you to go ahead and save that picture to your iPad or to whatever device you're working on, right? You'll be able to use this on your next, on your final, right? So kind of definitely on all your assignments as well, right? Make sure you have this somewhere where you can access pretty easily. Okay, so that's what we've been kind of doing for the past section, right? Going ahead and evaluating these trig functions at these different angles, right? Now I kind of want to go backwards a little bit, right? So here I have that sine of 240 degrees is equal to negative rad 3 over 2. What if I kind of went backwards and asked the question, sine of what angle is negative rad 3 over 2? Okay, and then I kind of repeat the process with the rest of these questions, right? Cosine of what angle is 1/2? Tangent of what angle is -1 over rad 3, right? I can kind of ask that question, and if you think about it, it's kind of similar to back in the exponentials, right? Whenever we have, okay, what is 2 to the 3rd power? Instead of asking that question, 2 to what power? is equal to 8, right? We're kind of doing that little backwards process. And so what's going to happen here is to answer this question, we need inverse trig, right? Because remember, log was the inverse of exponential, and so that's why we needed logs to answer this. Okay, it's not as simple as saying, oh, it's 240 degrees, right? Because the issue is that the inverse trig, whenever we use inverse trig, it's a function, has to follow function rules. The main one being for every input, there is exactly one output, right? And so if I input an angle, I should only get one answer. But then when I do inverse trig, when I input a number, I should only get one angle. But the issue, for example, if I look at this right here, this question, sine of what angle is negative rad 3 over 2, I'm looking for ordered pairs that have a y value of negative rad 3 over 2. We have a couple that satisfy that description. We have this one that we found earlier, right, the 240 degrees. But then we also have this one up here, 2 pi over 3 or 120 degrees. Now, if this were a true function, I can have both of these answers at the same time. And so that's kind of why we need to specify things a little bit here, right? So when I do inverse trig, here's kind of the deal. So we're going to start with sine. When I take the sine inverse of some value a, what's going to happen is I'm going to spit out a theta, right, an angle. So in inverse trig, the output is always an angle, right? The output is an angle. Okay, and we're used to sine of theta is equal to a, where the input is the angle, but not in this case. Right now we're doing it backwards, right? Inverse functions, they switch the input and the output. Now a is some ratio or some value that we see on our unit circle in these ordered pairs. And our theta is going to be an angle, okay? So now there's a couple rules that go with that. Okay, my domain, I'm gonna do this in a different color. The domain of this function, so the a's, have to be between -1 and +1. So I can't plug anything into the inverse function if it's outside of this domain. So I couldn't plug in -2, I couldn't plug in 2, right? And then my range, okay, so the angles that this can be is from -pi/2 to pi/2. So that means if I look on my unit circle, if I'm looking on the unit circle for my answers, then the only answers that I will find are from this section of the unit circle, the right-hand side, the side that's in quadrant 1 and quadrant 2, or that is not quadrant 2, quadrant 4, I apologize, right? And so that makes sense because down here is -pi/2 and up here is pi/2. And so everything in between is what my angles can be. Okay, and I can do the same thing for the other, or two of the other trig functions. So I can do cosine inverse of a equals theta. Okay, my domain is actually going to be the same. It's going to be from -1 to +1, but then my range is going to be from 0 to pi. So then all the answers that I can get from this function are on the top half of my unit circle. Okay, because that's where 0 to pi is. We know 0 is right here and pi is over here. So then all the answers are going to come from here. Okay, we're going to kind of explain what that means here in a little bit. So if you're a little confused by like, what do you mean by the answers, right? Okay, and then the last one, tangent inverse of a is equal to theta. Okay, the domain for this one is completely different. It's actually going to be all numbers, right? All real numbers from -infinity to +infinity. And then my range is going to be similar to the range for sine inverse, but it's going to be parentheses instead of brackets. Okay, and that makes sense because remember, when I take the tangent of these two angles, it's going to be, for example, if I look at pi/2, up here, 1, 0, y divided by x, 1 divided by 0, undefined, right? And so that's why we have to make sure we don't include those. Okay, so the little picture for this one is going to be the same as sine inverse. Okay, it's going to be from here to here, but little open circles showing that, okay, I'm not actually going to get any answers from there, but this is kind of where the answers range from, okay? In quadrant 1 and 4, like with the sine inverse. And then cosine inverse was quadrant 1, and this time quadrant 2, right? Okay. And so that's kind of some base information we're going to need to know, especially when we're finding our answers for the next following questions, right? Like the answer to sine of what angle is negative rad 3 over 2. So kind of going back a little bit, you're actually going to just kind of a word of the future. And when you go into pre-calc, and if you eventually end up going to calculus or a higher level math class, sometimes you're going to see, instead of sine inverse, you might see arc sine of A. And actually, not even if you go to a higher math class, sometimes when you take like, the ACT or other tests that, we are outside of this class, but use this information, you might see arc in front of the sine instead of sine inverse to the -1 power. And then, so just kind of keep that in mind. These are the same thing. These mean the same thing. This is sine inverse. The reason why they do that is because this notation right here is a little confusing. And the reason why I think it's confusing is because we have this -1 looks like an exponent, but this is not an exponent. These are not exponents, even though they're where the exponent should go, right? It's like when we talked about f inverse of x, okay? This is not an exponent. That's just notation, okay? So notation, not an exponent. Okay, we're never going to raise trig functions to a -1 power in this class. So don't worry about having to mix the two up. Whenever you see to the -1, that means it's the inverse function, okay? Cool. So now let's use that information to evaluate the following inverse trig functions, okay? Give your answers in radians and degrees. We'll start with cosine inverse of 1/2. Okay, so this right here, this is asking the question. This kind of in English says cosine of what angle is 1/2. Okay, this is what this is asking. So what I can do is I can write a little theta right here, because then that kind of tells me, okay, I'm looking for an angle. My answer needs to be an angle in radians and degrees, right? So I want to rewrite it like this. Okay, cosine of what angle is 1/2. This directly then becomes cosine of what angle is equal to 1/2. Okay, and our target is to find this theta. Okay, so what we need to do is go to our unit circle above. Okay, and I'm going to rewrite what we're looking for, right? So cosine of theta is equal to 1/2. That's what we're looking for in green. I'm going to erase this. Okay, so cosine of theta equals 1/2. Remember, cosine of theta is the x. So that means I'm looking for any x values in these ordered pairs that are 1/2. Okay, so let's go ahead and take a look. Let's see if we can find any. So I'm looking kind of at, let's start in the first quadrant. I'm looking, here's one. Okay, so this right here is one potential candidate. Okay, so in this case, pi over 3 or 60 degrees, because they have a 1/2 in the x value. Okay, let's move to quadrant 2. Here's another one, but notice how this is -1/2. So I don't want to use that one, okay? That's -1/2. I'm looking for +1/2. Okay, don't see it anymore. Here's another -1/2. I don't want to use that one. Oh, here's the other one. Okay, the other one is at 300 or 5 pi over 3. Okay, so those are my two options, okay? And I'm going to write them both down. So my options were pi over 3 or 60 degrees, okay? Or the other one was 5 pi over 3, 300 degrees. Okay, they both can't be the answer, right? Notice it looks like there's 4 different answers, but these two go together and these two go together could be because they represent the same angle, right? They're just in different units. But again, I can't have more than one answer because this is a function. So now here's where I use this range. Okay, my range is 0 to pi. So I'm going to write that down. My range is 0 to pi. Which one of these is between 0 to pi? This one right here. This one is our answer. Okay, because pi over 3 is between 0 and pi. If you want to, you can go back and on underneath each of these little ranges, you can rewrite them using degrees if you're still kind of needing a little bit of help. So this is 0 degrees to 180 degrees. Okay, this one is negative 90 degrees to positive 90 degrees. And then same thing for this one, just using parentheses. Okay. If you need this to help you a little bit because you're still kind of working on being fluent between radians and degrees, then please write that because I'm going to ask you for both of the units anyway, right? So my range in this case had to be between 0 and pi, or 0 degrees and 180 degrees. And so now maybe it's a little bit easier to tell, oh yeah, 60 is between those two, not 300, right? Cool, so this one is our answer, pi over 3 or 60 degrees. So cosine inverse of 1/2 is equal to this right here. Let's try one more, let's try a few more. Sine inverse of rad 3 over 2. So then I'm asking this question, right? Sine of what angle? So what angle theta? Sine of what angle is equal to rad 3 over 2? Oh, and that actually should be negative, I apologize. This should be negative rad 3 over 2. So then we write, this directly translate then to sine of what angle is equal to negative rad 3 over 2. Okay, we don't need to write the English translation every time, just that is what you should think of in your head when you're looking at this, right? Sine of what angle is negative rad 3 over 2. Okay, so that's what we're going to look for. Sine of theta is equal to negative rad 3 over 2. Let's go back to our unit circle up here. And I'm going to write my goal, what sine of what angle is negative rad 3 over 2 in this purplish color. Maybe like fuchsia, maybe, I don't know. I think it's purple. Okay, so I'm looking for a y value, since it's sine of theta, of negative rad 3 over 2. Okay, so I'm looking for a negative rad 3 over 2 in the y values. So I have, let's see, starting quadrant 1, no, I wouldn't use either of these, right? Because these are both positive rad 3 over 2. If I go down, oh, here's the first one. So 4 pi over 3 or 240, and then here's another one. Okay, 5 pi over 3 or 300 degrees, because these both have y values of negative rad 3 over 2. So I'm going to write my two options down, 4 pi over 3, 5 pi over 3. Okay, so my options. I can do 4 pi over 3 or 5 pi over 3. Okay, sorry, I wanted to write the radians first. I'm a lot more fluent in the radians than the degrees, believe it or not. I have a bit of a hard time with the degrees sometimes. 300, and then this one is 240. Okay, so those are our options. Now, if I write the little range for sine inverse, it goes from negative pi over 2 to pi over 2, or negative 90 to 90. Okay, so I'm gonna write that down. So my range goes from negative pi halves to pi halves, or negative 90 to 90. Okay, we're in a little bit of a pickle here because if you look, none of those actually fit in those ranges, okay? But not all hope is lost, okay? Because what I can do is I can kind of rewrite these as coterminal angles, okay? So that's kind of where coterminal is going to help us a little bit here. If none of these angles look like they work, first try to get them to be coterminal, okay? So looking at both of them, they look pretty big compared to my degree range, right? They're both above 90. So what I'm going to do is subtract 360 from each of the degrees, okay? And I'm going to work with the degrees because it's a little bit nicer to show you in degrees, right? So if I do 240 minus 360, I shouldn't really need a calculator for this, but here I am using the calculator. This is negative 120 degrees. And then if I do this one's not a lot nicer, negative 60 degrees. Now it's a lot more clear. Oh, look at that one. Negative 60 degrees is in there. Okay, that's the right one. This one is not going to work because this is negative 120. Okay, so my answer, I have to keep it in the negative 60. I'm not going to box this. I actually need to keep it in that negative 60 degrees. And so then I'll need to subtract the 2 pi from 5 pi over 3. So 5 pi over 3 minus 2 pi. That's going to be, this is the same thing as 6 pi over 3. Ooh, my little drawing board is lagging a little bit. 5 minus 6, that's negative pi over 3. So those are my answers, okay? In radians, negative pi over 3. In degrees, negative 60. All right, whenever you see the negative inside the sign, you're going to have to do a little bit of this extra step to get it to look nice, to make sure it's in the range. Okay, just know that just because you don't immediately see, oh, right, neither of these are in the range, you might need to do a little bit of coterminalizing. Okay, I just made up that word on the spot. Last example for this one, sine inverse of 2. We don't really have to do anything here because look at 2. What is our domain for sine inverse? -1 to +1. No solution. Because our input is 2, input relates to domain. Domain is -1 to +1. This is a 2, definitely bigger than 1, no solution. Okay, so it's always worth, make sure you check the input, make sure that you can actually evaluate this, right?